Smart people, let's get this problem fixed. And this is coming under exponential function in calculus. So we're asked to find the derivative of y with respect to x for this particular function, y equal to exponential 2x into 2 cos 3x plus 3 sine 3x. So there are about two things I want to introduce to you guys. If you're able to get that concept clearly, then you can be able to work on this particular problem. So the first one is for you to be sure that you're familiar with this particular one. The derivative of exponential x with respect to x, the result to that is exponential x. So when you're taking the derivative of exponential x with respect to x, the result is exponential x. However, if you're taking the derivative of exponential 3x or 4x or 5x with respect to x, the first thing you want to do, you have to bring this 3 down and then repeat the exponential 3x. Now this is shortcut. I'm not using the main process. We'll be using chain rule, which is functional to fix this. This particular one is just a shortcut for you to be able to do stuffs like this. All right, so this is the first thing I want you to be familiar with. The next thing I want you to be familiar with is about this particular sine and cosine. If I have, say, 4 cosine 2x, and I ask you to take the derivative of 4 cosine 2x, I expect you to use this particular 2 to multiply by the number you're having here. Whatever it is you're having here, use it to multiply by the number you're having, and that gives us 8. 2 by 4 will give you 8. And then what is the derivative of cos? Keep in mind, the derivative of sine x is going to be cos x. In fact, it is cos x. The derivative of cosine x is negative sine x. And the derivative of tan x is sec square x. Let me repeat that again. The derivative of sine x is cosine x. The derivative of cosine x, remember I'm saying cosine x, not cosine 2x. The derivative of cosine x will give us negative sine x. So now we have cosine here. So the derivative of cosine is negative sine. We have to repeat this 2x. Remember, the first thing you have to do is to use this 2 to multiply by any number you have here. That gives us 8. And then change the derivative of this cos to negative sine. Repeat this one. So finally, 8 multiplied by this will give us negative 8 sine 2x. This same process could be applied for when you have, say, maybe 5 sine 3x, stuffs like this. So the first thing you want to do is to take the derivative of, first of all, use this 3 to multiply by this particular 5. That gives you 15. Now, what is the derivative of sine? Like I said before now, the derivative of sine is cosine. Then repeat this number 3x. So that's how you can differentiate this. Pretty simple, right? Okay, so those are the things we're going to be applying for this particular problem to get that fixed. So the first thing you want to do is to examine the problem. You have to find the y over the x for this particular function. So first of all, I'm seeing exponential 2x. That comes under the exponential function. And I'm seeing also trigonometrical functions, which are these 2 cos 3x plus 3 sine 3x. So the first thing I want to do right now is to apply another rule called the product rule. Why? It's because this exponential 2x is multiplying the whole of this function. Because I have that product multiplication, that means I have to use the product rule to get this fixed. So what is the product rule? The product rule says that I can have this particular function, exponential x, say let exponential 2x, or say let u be equal to exponential 2x. That means I need to replace the whole of this by u, and also for this one, I can say v should be equals 2 cos 3x plus 3 sine 3x. So v should represent the whole of this, and u, I think I need to swap this. I like it when I say let u be equals this one, exponential 2x. It makes a lot of sense like this. Okay, so what's next thing you need to do? Since you have assumed that u should be this and v should be this, you have to take the derivative of this particular u with respect to this x, and also take the derivative of this v with respect to x, because I'm having x over here, and then I'm having x also on the right hand side. So I will take the derivative of this u with respect to x. Remember, this is where I was showing you 1 or 2 points that you need to take note of. That the derivative of exponential x is also exponential x. But when you have the derivative of exponential 2x or exponential 3x or exponential, depending on the number you're having there, bring that number down and then repeat exponential 2x. Instead of going through the process of using chain rule, which is a function of a function, this is pretty easy. So let's do that to this. Let's take the derivative of v with respect to x. Now, what you need to do is to apply that same method I told you, that shortcut. That the first thing you want to do is to use this 3 to multiply by this 2. And remember, the derivative of cos is negative sign. So I'll have negative 3 times 2 gives you 6. And then cos changes to sine. Then repeat the 3x. Oh, that is pretty simple. Then here we have a plus. 3 times 3 gives you 9. Derivative of sine will give you cosine, then repeat this 3x. Pretty simple. Pretty simple. So the next thing you want to do is that you need to introduce that formula for product rule so that you can be able to drag all of these things and drop into the formula, and that will be all. Let's do that very quick. The formula for product rule is dy over dx. Please take note of this formula. Equal to u dv over dx plus v du over dx. Pretty simple. So what you need to do now is to drag. Remember I said drag and drop. I have to drag this one and drop. Like this is u, this is u. So I'll have to drop the what u contains. And I replace it here. Also for dv over the x, this is dv over the x. I have to substitute this for this. And then v is this one. I have to substitute this for v. And then du over the x is this one. I have to substitute this for this. Pretty simple. So that's why I call it drag and drop. So I have dy over the x equals, your u is exponential to x times dv over the x is the whole of this one. So put it in parentheses. I think I prefer to use the parentheses so that I can just have house all of this. 6 sine 3x plus 9 cosine 3x. That was for dv over the x. Then bring down the sign plus. Your v is the whole of this. So I'll have, let me put in the parentheses also. 2 cosine 3x plus 3 sine 3x. And the whole of this will multiply by, what is your du over the x? Du over the x is 2 exponential to x. Now this should be the answer, but obviously you can't just have something multiplying this and just leave it like that. Having this one multiplying this, let's expand, collect like terms, and that will be all. So let's fix that right quick. Please make sure to share this particular video and like this particular video. If this is the first time you're seeing this video or meeting this particular page, please make sure to hit the subscribe button. Turn on the bell icon so that when I upload new video, receive notification. All right, so if exponential 2x multiplies by this first term, it will just come and replace, or not replace, it will just come and join, add up to this particular one. So that gives us minus 6 exponential 2x sine x. It's not going to change any number. Instead, it's going to add up because it's multiplying. Okay, so let's move to the next term. Exponential 2x times 9 cosine 3x will give us 9 exponential 2x cosine 3x. Let's do that for this one across this. So bring down the sign, plus 2 exponential 2x multiplied by this. Remember, 2 multiplied by 2 gives us 4. Please be careful when you're doing this. 2 multiplied by 2 gives us 4. Then bring in this, you can bring in the exponential, 2x, then cosine 3x. Do same for this. 2 times 3 gives you 6. And then exponential comes in, exponential 2x. Then repeat this one, which is sine 3x. I think we're pretty done with this. So the final thing you need to do at this particular point is to check what are the common terms that we need to add up or subtract, as the case may be. Let me focus on this. I'm seeing cos 3x, and I'm seeing exponential 2x, exponential 2x. Then I can be able to add. So 9 plus 4, therefore dy over dx will equal to 9 plus 4 should give us 13. 13 exponential 2x cosine 3x. That's for these two. Then what about this? This and this, look at sine 3x, exponential 2x, exponential 2x. Negative 6, positive 6. That means They are having the same content. So this minus, more like you're having 2 minus 2 plus 2. So minus this plus the same thing gives you 0. So that means this can easily cancel out with this particular one. And then this sum up to give us this. So this is the answer for this particular problem. So we have been able to find the derivative of y with respect to x in this particular video. And I hope you found this particular video helpful. Please make sure to hit the like button, share this particular video, and make sure to hit the subscribe button if you're new to this particular channel. Until next time, I'm going to see you. Peace out.